Today we will be continuing with the topic algebra, and we will be doing laws of indices, right? Well, the first topic. So there are some basic laws that we use when we are working out indices, and indices can be called powers, they can be called exponents, right? So three words all mean the same thing. That little number that flies or hovers over your variable on the right hand side is called your index or your power, right? So the first rule we have is that any variable or any number, right? Any number raised to the power of 0 is 1. So whether I have 100, so whether I have 100 raised to 0, that will give me 1. And we can put that into our calculator by pressing 100, the power sign, 0, and equal, you'll get 1, right? Anything negative 20 raised to 0, that's 1. So the second rule says, which we are familiar with, when two same variables are multiplying by each other, you add the powers. So you have 2 to the power of 3 multiplied by 2 to the power of 2. You know, your answer is just 2 to the power of 2 plus 3, which is 2 to the power of 5. Or x squared multiplied by x5, we know that that's just x, 2 plus 5, which is 7. Same thing, y5 divided by y3, we just say that's y5 minus 3, which is y squared, right? So the part D, any variable raised to a negative power, we can send that variable and its power in a denominator and make the power positive. So let's say we have 2 to the power of negative 3. If I want my 3 to be positive, I just put it as the denominator of 1, 2 to the power of positive 3. So let's say I had something like this, 2a to the negative 2. And I want my a squared to be positive. I'm going to leave the 2 on top. And then I'm going to put a squared at the bottom, right? Same thing, if I want the a squared to be negative, I can send it right back up and make it 2 multiplied by a to the negative 2. All right, so I have a variable to a power raised to another power. So when I have a power raised to another power, we just multiply them. So y cubed multiplied by 2, so that will give me y to the power of 6. All right, 2 to the power of 4 squared will just be 2 to the power of 4 by 2, which is 2 to the power of 8. This last one here, a raised to the power of a fraction. So like 2 raised to the power of 2/3. This is going to be, we take the denominator of the fraction and make it into that root. So it's going to be cube root 2 squared, right? So we see m, the numerator stays as the power, and the denominator goes into the root function. And we can put any root into our calculator using the root sign, right? So if I have a to the power of 5 over 6, this is going to be the root 6 a to the power of 5. So these rules will help us maneuver and work out our algebraic simplification questions. So let's attempt these 3 questions on the screen. So this is multiplication of algebraic terms. So we say 3 by 2 by 4, that is 6 by 4, which is 24. Then we multiply all our common variables. So x to the power of 5 by x to the power of 4 by x, which is just x to the power of 1. So that's going to be 5 plus 4 plus 1. So that's x to the power of the sum of all those indices, which is 10. And then y by y squared, that will be again 1 plus 2, which is 3. Example 2, this is a division, so we know we're subtracting like powers. So this could also be written as 8 x to the power of negative 5y divided by 2x cubed y to the power of negative 4. We could easily see it this way, that these two could cancel out, which is giving me 4. Negative 5 minus 3. So that's still going to be negative 5 minus 3, right? So that's going to be x to the power of negative 8. And then we have y, 1. This is a 1 minus negative 4. Don't forget that it's a negative 4. So 1 minus negative 4, that is actually 1 plus 4, which is 5. So y to the power of 5. So again, we learned the rule that if we want a power to be positive and not be negative, we could send it into the denominator. So this could be 4 y to the power of 5 all over x to the power of positive 8. That's how nice and simple it works. So let's try this one here. This goes back to our rule, our second to last rule with powers. A power raised to another power. Excuse me, right? So 3x to the power of quarter, y to the power of a half is all squared. So that means every term inside that bracket is squared. So it's going to be 3 squared by x to the power of a quarter squared by y to the power of a half squared. Every single term, not just the number. So that's going to be 9. We know that we multiply powers. So that's going to be a quarter by 2. So that's x 2 over 4. And then y 2 over 2, because we're just multiplying a half by 2 and a quarter by 2, which we can now simplify as 9 x to the power of a half y to the power of 1, because 2 over 2 is 1. So we just put it as y. So let's work out 25 to the power of a half without our calculator, right? So what we're going to do, we're going to change 25 into index form. So what number could give me 25 in index form? So this is going to be 5 squared, which is still 25 to the power of a half. This carries us back to one of our indice rules. So we'll multiply powers, which is 2 by a half. So that's just 2 over 2. And this is just going to be 5 to the power of 1. So whether I put this entire thing into my calculator, I'll still get 5. Or if I'm required to work it out, showing the working, I could work it out this way and still get 5. So 32 in base form, 2 to the power of 5 is actually 32, right? And this is still to the power of 2/5. So we multiply our powers, so that's 2 by 10 over 5, which is 2 to the power of 2, which is actually just 4. And 27 to the power of a third, let's put 27 in base form, right? So this is 3 cubed, right, to the power of a third. 3 multiplied by, so that's 3 over 3. And then we have 3 to the power of 1, which is just 3. So if this was negative now, 27 to the power of negative a third, still 3 to the power of 3, all right, to negative a third. We can still say 3 to the power of negative 1. And if we don't want our answer to be, again, negative, we just put 1 over 3 to the power of 1, right? But we don't need to put it in because it's just a 1. So 1 over 3. Let's try 8 over 27 raised to the power of negative 2 over 3. So what is happening here is we can, if I have something like this, a over b to the power of 2, I can simply just say this is a squared over b squared, because remember, everything in the bracket has to be squared, right? Just like when we did a, b all squared, it would have been a squared, b squared, right? So I can say a to the power of negative 2 over 3 all over 27 to the power of negative 2 over 3. This is just one way, right? And we could work this out. Again, put 8 in a base form. So 2 to the power of 3 is 8. So 2 to the power of 3 by negative 2 over 3 all over 3 to the power of 3 is 27 to the power of negative 2 over 3. And we can multiply out our powers. So that will be 2 to the power of negative 2 when we simplify it, all over 3 to the power of negative 2, right? And if we want to make this positive, of course, we had to do something nice here. We're going to send down the 2 to the power of negative 2, which is to make it positive. So that will be 2 squared at the bottom. And of course, if we want the 1 at the bottom to be positive, we send it up. So that will be 3 squared. So that would just be 9, right, over 4, which is 2 1/4. I love this question, right? You really have to pay attention and do it step by step. So let's do this again. We separated numerator and denominator. So 8 to the power of negative 2 third over 27 to the power of negative 2 third. We change 8 and 27 in base form, which is 2 third to the power of negative 2 third, and 3 cubed to the power of negative 2 third. We multiply these out, which will give us negative 2 and negative 2. And in order for us to work this out, we need to make the powers positive, especially if we're doing this by hand. So I send the 2 and the negative 2 to the power of negative 2 to become positive in the numerator, and I send the numerator to be positive in the denominator. So that's how we got 3 squared on top and 2 squared at the bottom. And we know 3 squared is 9 and 2 squared is 4. And we simplify that as 2 1/4. I think another way we could try this is 8 over 27 to the power of negative 2 third. The first thing we could do is send this entire thing in a numerator to be positive. So that'll be 1 over 8 over 27 to the power of positive 2 third. And then we do the same thing again. 1 over 8 to the power of 2 third divided by 27 to the power of 2 third. So this is 1 over all of this, which will be 1 over, we do the same thing, change the bases of 8 and 27. So that will be 2 cubed to the power of 2 third divided by 3 cubed to the power of 2 third, which will give us 1 divided by this will still be 2 squared all over 3 squared. So this comes like this, right? 1 divided by 2 squared over 3 squared. We know the rules for division. Change the multiplication. So 1 multiplied by 3 squared over 2 squared, which is just 1 multiplied by 9 over 4, which is just 9 over 4, which is 2 1/4. And nobody wants to go through all of this, right? But I think it's lovely, lovely to, really understand these steps and to be able to take your time and go through this. So I will definitely go for option 1, right? So we have 2 questions on the board, and they are telling us to solve the equations. So we have 2 to the power of x minus 1 over 4, which is equal to 64. The first thing we'll have to realize is that we can put 64 over 1 and do cross multiplication, right? So the base is going to multiply by the numerator, denominator by numerator on the other side. So 1 by 2 to the power of x minus 1 is just 2 to the power of x minus 1. And 64 multiplied by 4 is 256, right? Now, in order for us to solve this again, we need to have same bases. So more than likely, when you get questions like these in the exam, the numbers are not going to be so big. It's going to be a number where you can easily make it into base form, right? So 2 to the power of x minus 1, you're trying to make 256 into a number that is 2 to the power of something. So I can go to my calculator. Even if I don't know, I could go to my calculator and try numbers. So I could put 2 to the power of 10. Whoa, I got 1,024, that's too big. I could put 2 to the power of 5. I got 32. I could put 2 to the power of 8. I got 256. So I say, okay, that's my number. 2 to the power of 8 will give me 256. So once we are back with same bases, if I have 2 to the power of x minus 1 is equal to 2 to the power of 8, these two things are equal to each other. So that will just mean that x minus 1 will have to be equal to 8. And in order for me to solve for x, I could just add 1 and add 1 on both sides because I want to get x by itself. So that will be x is equal to 9. So that's how we solve for x here. But I won't go too deep into this because we haven't done solving equations as yet, right? So I'll just do the second one here, but I just want you to see how the rules for the indices can come into play. So we have 7 by 7 to the power of 2x. So I know you all will come and hit me this, 49 2x. Remember the rules. This is to the power of 1. Once you have two same bases, you add the power. So that will be 7. 1 plus 2x or 2x plus 1, anyone, which is equal to 49 by 7 to the power of x. I could put 49 in a base of 7 to work it out. So that will be 7 squared by 7x. So that will still be 7. I'm just going to put 2x plus 1, which will be 7, 2 plus x. So again, once they are in the same base, the powers will have to be equal to each other. So that will be 2x plus 1, which will be equal to 2 plus x. Now, what I'm going to do is solve for the x's. So I have to put all my x's on one side. So I'm going to subtract x from here and subtract x from here. So 2x subtract x, which we already know how to do. 2x subtract x is 1x or just x. So we end up with x plus 1, which is equal to 2, because x minus x goes to 0. 2x minus x goes to x, and we have this 1, right? So x plus 1 is equal to 2. Again, we're solving for x, so we're going to minus 1 on both sides. So 1 minus 1 is 0, so that's going to be x. is equal to 2 minus 1, which is 1. Have no worries. When we go into solving linear equations, we will definitely revisit this and you will have a better understanding of how to go about it, but just focus on the powers. So we realize that we put it in the same base, we put the indices equal to each other. This one now, we saw that it was very easy for us to put 49 to the power of 2x. But remember, once they are the same base, we add the powers, so that's 1 plus 2x. And you can't come and put 49 by 7, no, because it's 7 to the power of x, so we put 49 in base 7, so that's 7 squared multiplied by 7x, and we 7 to the power of x, and then we add them to plus x, and then we put the powers equal to each other and solve accordingly.